Justin Gorecki.
Chris.
Okay, this is our bridge PowerPoint. The history of the Warren Truss, which is the truss that we ended up choosing for our bridge design, was patented in 1848 by James Warren. And the Warren Truss is very reliable because it ensures that all of the tension and compression forces are distributed equally within the truss. Some other fun facts about the truss is that it's used in old-time airplanes, like as you can see in that picture right there, and each of the struts forms equilateral triangles, and that's just an aesthetically pleasing feature. Why did we choose the Warren Truss? Well, we chose the Warren Truss because in history it has proven to be a very stable and economically reliable truss to use, because it doesn't have like all of the extra unneeded joints on other types of trusses. It's also an easier truss to build because of the fact that it has less members, and it's not a politician again. Some of our MD solids data shows that each of these are evenly distributed. It's at 55.9 for each of those angled members. How we built it, we first rolled up 4 pieces of paper. We taped them lengthwise like this, and then after that we taped it up, glued them up, and sometimes we had some problems with the length of them, so we did have to saw those down to make them the right length to fit into our bridge.
And the struggle is, this thing was too heavy. At first we had 2 members on the top joint, but like it was too heavy, so I had to take it out. So, yeah, since like we took the 2 members out, and when that thing was pulling it down, so at the end, kind of the top just went joined together, because yeah, there's nothing like supporting on top. And the data shows that our bridge held 72 pounds. Like the thing going, like the vertical thing, it reached a limit, and on the machines that's lower limit ridge. So like, I think this happened because of our like really long members, and just bent down so much it couldn't test it anymore. So like the weight we got at 72 pounds, and it never failed because nothing broke on my bridge. And here's the data. So like at the displacement at point 2 was 25 pounds, as you can see. Like the lowest you can reach for displacement is 1.32 inches. It was at 72 pounds. And reflections, if we could build this bridge again, we would have like build smaller members. So like maybe like stronger members on the bottom. So like when we test it, it doesn't reflect that much. So maybe it could hold more weight. And we could make the bridge a little bit shorter and smaller. So like at first our bridge couldn't fit in the machine, so we had to like saw some members out. Yeah.
That's it.